So this is an exciting week because we will be talking about decision trees. And decision trees are a very popular model choice. They are, as you'll see, a tree is a little easier to understand and interpret than a different kind of model like logistic regression. And ensembles of trees, which are harder to interpret because sometimes they're ensembles of many, many trees, but they're often used to win machine learning competitions. So I think I've mentioned Kaggle in the past. That is Kaggle.com. They host machine learning competitions as well as a really nice set of learning competitions. I really encourage you, if you're interested in this kind of thing, I encourage you to check that out because nothing beats just experience and working, and it's a great site to learn and learn from others as well. Anyways, often on Kaggle, ensembles of decision trees will win competitions. So before we jump into what is a decision tree, we need to import the libraries we will use. So we usually have this cell at the top of our notebook. So we'll run this now. Oops, or run this. Now, one thing that you may not have installed is GraphViz. And so you may run this cell and you'll get an error saying GraphViz is not a package or is not installed. That's okay, we can install it. So the way you would install it is, so here I'm in Anaconda Navigator, and what you would do is you would click on environment on the left here, and then you want to choose the environment you've been using for this course. Now, this is really important that you listen to what I'm about to say because I get a lot of emails on this. You will only have one environment. So if you installed Anaconda for this course, you will only have one environment. That's fine. And likely the name of your environment will be Anaconda or root. And that's fine. That's totally fine. So you won't see these other, I don't know how many, like 10 or 9 others that I have. I have these because I'm doing stuff, just doing too much stuff. And so I have different environments for different things. But you'll just have one, and that's okay. Just use that one that you have. Nothing wrong with that. But for this course, I'm using this environment. And so you would click here, and then you would go over to the not installed. So from this drop down, you would choose not installed, and then you'd scroll down. It's alphabetical, so you'd scroll down to GraphViz, and you would click the green. So obviously, because I have GraphViz installed, it does not show up on the not installed thing, the list here, because I already have it installed. But let's say this was GraphViz, you'd click on it, and then you'd click apply, and that would install it. So just so you can see in my installed list, if I scroll to, there we are, so you can see that I have it installed. Now, if that does not work, sometimes when I have installed things or tried to install things with Anaconda Navigator, it will freeze up. Definitely give it time. Give it a few minutes. Don't if it's taking more than a few seconds, let it go. But sometimes it seems to never stop, so it hangs for some reason. I don't know. If that happens, you can go to your command line, and let me just clear this. You can go to your terminal. So if you're on a Mac or a Linux, you can go to your terminal. If you are on a Windows machine, you can go to the Anaconda prompt, which was installed with Anaconda, and it will look similar to this. So it'll have this similar feel where you can type in commands, and you would just type in this command, conda install python graphviz. And then you'd hit enter, and it'll take a few seconds, but then it'll give you an option to install. And this almost always works for me. So I'm going to interrupt that because I already have it installed. But if you let it sit there, sometimes it can take, maybe 10 seconds. So let it run until it prompts you to OK the install, and then you can OK the install. If you are one of the very rare students that actually has multiple environments in Anaconda, so this is only going to apply to maybe none of you, but for those that do, if you had the list here, if you had multiple environments and you made a new environment for this course, which again is probably none of the students, maybe one out of every few classes. If you did, then if you're using this terminal method, you have to activate that environment before you install it. So you type sort activate, source activate, and then the name of your environment. So I would type this, and I actually was already in this environment. So you can see the UCI Python in parentheses to the left. This was telling me I already have this environment activated. You'd want to activate it, and then you'd run the install because you want to install it for that environment. Now, if you're one of the very rare students that has multiple environments, you probably already know this. So even if this applies to you, probably already know what I'm talking about. For all of you or the majority of you, the last 2 minutes didn't even apply. So you can just follow the instructions before that. All right, very good job. And I will see you in the next lecture. All right, welcome back to the course. So now we will introduce decision trees. And I think a good way to introduce what a decision tree model is to play a game of 20 questions. So everybody's played 20 questions, so it's a good way to introduce the decision tree. So let's pretend we're playing a game of 20 questions. And I say to you, I am thinking of a sport. And you have to ask questions. They have to be yes or no questions, right? And you have to ask up to 20 to try and figure out what sport I'm thinking of. And so with each question, you're trying to narrow down, right, the set of possible answers. So you probably wouldn't ask me if the sport involves movement, because every sport involves movement, or almost every sport. So that doesn't really help you, right? That doesn't narrow down the possibilities. If I say yes, then you're still left with every possible sport as an answer. But you might ask if it's a team sport, right? And depending on my answer to that, you might ask if it involves catching. So you could probably think of some even better questions that would really narrow down, right, the set of possible answers effectively. And that's, of course, the whole point of 20 questions. The whole point is to ask really good questions that very quickly narrow down the set of possible answers. So let's think of another game. So I say I have a pet, and it's a cat or a dog. You have to ask 20 questions to determine if it's a cat or a dog. So what would you ask? Right? I'm sure immediately you're already thinking of questions that, and maybe in one question, right? You don't even need 20. In one question, you could probably determine if it's a cat or a dog. But you wouldn't ask if it has a tail, because that doesn't narrow down at all, right? Cats and dogs have tails. That doesn't help you. You might ask if it likes to play fetch, right? I'm sure you can think of other questions. So let's consider one more example. This is now from the data we've been working with. And I tell you, I am thinking of a student in our training data set. I'm looking at a row, which represents a student in our training data set. And I need you to ask me 20 questions about the training data and then guess if the student passed or failed. So what would you ask me? Right, and of course, you can't ask me if they passed or failed. You have to ask me questions about their features that we know of. And in this case, right, their features are the data we've been working with. So what would you ask me? You might ask me if they have a history of failures. Do they have greater than 0 failures? Remember, it has to be a yes or no question, a true or false. So do they have greater than 0 failures? The reason you might ask that is because all of our work, right, in the past 4 weeks, we've learned that that's a very good predictor of failing in this class. That might be one of the first questions you ask. You might ask, so I'm thinking back to week 2, I'm thinking of our visualizations, which features we saw had a larger impact. I'm also thinking of the features that the logistic regression ended up using. So one was, does the student go out, right? One of the features in the logistic regression was how much the student went out, right? That's one of the features. So you might ask if go out is above 1 or maybe above 0. You might ask if the student is interested in higher education. I'm thinking back to week 2 again, and I remember that was, I think, one of the features that if the student was not interested in higher education, they were more likely to fail. So point is, you would try to think of the best questions, and order would matter, right? Order matters. So you ask one question to try to divide up the students, and then depending on what I say, you try to ask another question to further divide the, I should say, to get further information that will help you be more confident about guessing if the student passed or failed. So let's go ahead and diagram some of the questions we might ask. Here I've only diagrammed 2 questions. So this is a very small decision tree, but the first one is, does the student have greater than 0 failures? If we say yes, so if they have any failures at all, then you might just stop there and you might say, okay, I guess that they're going to fail this course. Right? You won't be right 100% of the time, but you could say, right? I'm not saying this is a perfect tree we have here, but you might say, okay, if they have any failures, I'm just going to guess that they will fail. But if the answer is no, you ask me that, you say, well, does the student have greater than 0 failures? And I say no, then you might want to ask me another question for further clarification, right? You're trying to learn more so you can have the best guess possible. So you might say, or you might ask me, is the student interested in higher education? If I say yes, then you might say, okay, I think they passed, right? I think they're a pass in the data. Or if I say no, they're not interested in higher education, you might think, well, they don't have any failures, but they're not interested in higher education, so I'm going to guess that they failed. Now, you may be wrong, right? So I'm not pretending this is perfectly fit to our data, but this is a decision tree. We just made a decision tree. This is exactly what a decision tree is. It's a flow chart of questions that, depending on the answer, each question takes a different path. So if you say no here, it goes to another question. If you say yes here, it just stops at an answer. But trees can be very big. So instead of stopping at an answer here, we could have had another question that would have split into yes and no, and then another question, etc. So the blue boxes, the questions, are called the nodes. This is where, or they're also sometimes referred to as splits. So there's splits in the flow chart of questions, but these are nodes. And then where you finally have an answer is a leaf. It's called a leaf. So these are leaves and these are nodes. Of course, when we train a decision tree algorithm, we're trying to fit the flow chart that best fits the data. So we just came up with a flow chart kind of by thinking, right? We're just lightly thinking about what we've seen so far in the data. We're not doing any math or anything like that. But the algorithm actually does use math, and it tries to find the best flow chart that will fit the data. And by fit the data, I mean if you apply the decision tree to the training data, then it will get every classification correct. And we'll see that. That'll make more sense as we go on. So in the next video, we will look at how decision trees train, how they fit to the training data. See you in that video.